Hello, today I'll be demoing my mesh viewer, so let's get started. First of all, in our header file, we have a vector of vertices and a vector of triangles. Since we're using the index triangle structure, we count those to get data at the end, and we have a bunch of flag variables for other functions. We have our constructors, and we have functions such as setup, using a test shape, drawing selected triangles, and drawing adjacent triangles. Then we have our app where we have a bunch of objects for our camera and panels. Let's go into the code. First, we create a mesh and we load an object. So I have two types of objects that I will show briefly. This is based on a path that we give to this object. I also created this split helper function in order to split a line based on a delimiter, for example, a space or a backslash. Then our setup function, where I essentially create an empty vertex since OBJ files start at 1, at vertex 1. Then we load the mesh, we buffer it, and we buffer the lines. So we look for faces and vertices, and we add them to these arrays. We split that, then we try to parse it as a floating point number, and then we push it to that array, and we add to the count. I also added this little print that lets you know if the vertices are loading. Same thing for faces, pretty simple. We just add it to that temporary array. And then this is the interesting part, which is that this code works for any n-gon. So as you can see, we have here two different OBJ files. We have this one called woob and this one called teapot. So if I go here to the faces section, you can see we have 4 individual vertices. That means we have a quad, which has 2 triangles. If I were here in the teapot from the University of Utah, you can see we just have 3 vertices, which is 1 triangle. So the way this is stored in OBJ files is 0, 1, 2 is going to be the first triangle, and 0, 2, and 3 will be the next, and so forth. So I iterate through that, which should work for any n-gon. So the first one, then the next, and the next, and it works. Then we display the statistics in terms of memory for this shape. Also create this testing shape in case you want to try a pyramid or something simpler. Then we have our draw function, which just draws all the triangles that we have, and this adjacent function that draws adjacent triangles once we click a button. Then draw selected, which just draws those specific triangles. This is a function within draw adjacent triangles right here. As you can see, mesh the draw selected. And how do we parse the selected? So first we check if it's a face or a vertex. If it's a face, all we do is find the 3 adjacent triangles to that. That way we sample 2 vertices at a time. And then if an adjacent triangle shares 2 vertices, then that's an adjacent triangle. And then for vertices, all we do is check for a vertex and all the triangles that contain that vertex, which is pretty simple. Then we have our setup function, we set up the GUI, and we draw as well. So here we draw what I mentioned before. We can check if we want to draw a vertex, if we want to draw a triangle, otherwise don't draw anything. And that's about it. So let me show a demo. I'll start by showing the University of Utah teapot, which is a pretty simple example. And as you saw here, we have only 3 indices per face, 3 vertices per face. So this is what it looks like. We see that it has 3,644 vertices, 620 triangles, so it's about a ratio of 2 to 1. And this is the total memory and data that's being used. So why don't we go ahead and select something like number 500, and let's try to draw a vertex. So we can see a little fan that spawns into action right there. Let me find it. There we go. It's kind of clipping. We can see both sides of the object, so that makes it hard to find. But here we go. You can see there's this little fan sharing out that vertex. And then it's sampled by the triangle. So let's look for where that is. Triangle. Oh, I think I see it here in this ridge. This is going to be hard to see though. But you can see there's a triangle and the 3 adjacent ones. Let's try another number. Hopefully it's easier to see. Something like 1,000. Let's try that. Sometimes we gotta look for things. There we go. Much easier to see. So you can see the triangle in the middle and the 3 adjacent ones. And as I was mentioning previously, you can also try loading a more complex mesh, such as this character I created that I call a woob. I created this character in Maya and exported it with quads, just to see what it would be like to render using quads and how the data structure works. And any angle really should work for polygons of any size, which is, I think, is pretty cool. So let's select something like 500, and then let's look for a vertex. So here we see we select this little fan right here, and then we can look for the triangle. So you can see it selects triangle and the adjacent ones, just like that. And yeah, that's my little demo. Thank you, and I hope you enjoyed it.